Welcome to Hired NAT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. 4 seconds, 10 seconds. The browser finally errors out. The developer already allowed inbound HTTPS, so why is nothing coming back? Because there's a second firewall sitting at the subnet boundary, a network access control list, or NACL for short. And one missing outbound rule can take down the whole app. If you've been following this AWS Cloud Practitioner series, you already know the subnet itself. Now, we add the firewall layer everyone forgets. By the end, you'll be able to explain stateful versus stateless in plain English, not just memorize the phrase. You'll read or write a security group inbound rule and the matching network access control list return rule that statelessness demands. And you'll pick security groups for instance-level allow rules and NACLs for subnet-level deny rules. Both services are linked in the AWS docs if you want the raw reference. For traffic coming from outside a subnet, there are typically 2 separate filters to clear before it reaches a web server. First, traffic crossing into the subnet is evaluated by the Network ACL attached to that subnet. Then the security group associated with the server's network interface decides whether the traffic can reach the instance. One layer is stateful and the other is not, which changes what has to happen on the return trip. Traffic that stays entirely inside the same subnet does not cross that subnet boundary, so it is not evaluated by the NACL there. But the security group still applies to the resource. And for a subnet to be public, its route table needs a route to an internet gateway. Quick checkpoint from part 1. What single route table entry makes a subnet public in AWS? Think of your VPC as an apartment complex. The Network ACL is the security gate at the main entrance. It checks everyone before they can even reach the building's hallways. The security group is the lock on one specific unit's front door. Gate open, but front door locked? The visitor stops outside the apartment. Front door open but gate closed. They never get close enough to try the handle. That's the difference between a subnet-level filter and an instance-level filter. Security groups are associated with the resources they protect. On EC2, that usually means the instance's network interface, not with an entire subnet. That means 2 instances in the same subnet can have completely different access rules, and one security group can protect resources in different subnets within the same VPC. Because the security group stays with the resource, it can evaluate traffic between resources in the same subnet even when that traffic never crosses a subnet boundary. Think of a security group as the fine-grained access policy attached to the workload itself. A security group behaves like a club bouncer with a wristband system. You show your ID once on the way in. The bouncer records that you're approved and gives you a wristband. When you leave and come back, you don't get rescreened. The wristband proves the connection is already trusted. In network terms, that's stateful. An allowed inbound TCP 443 creates a tracked connection, so the response traffic exits automatically without a separate outbound rule. Fewer rules to maintain, fewer return paths to break. Security groups are allow only. You do not write a rule that says, deny this one bad IP. Instead, If no inbound allow rule matches, the traffic is dropped. A newly created non-default security group normally starts with no inbound allow rules, so nothing can reach the resource until you add one. Its default outbound rule is commonly allow all, but remember what that means. It allows return traffic, and it also allows the resource to initiate new outbound connections. Verify the rules in the console before relying on them. So to block an unwanted source, allow only the sources you trust. For example, to let yourself in over SSH, create one inbound rule for TCP port 22, assuming your server uses the default SSH port, and set the source to your own public IP or a narrow trusted range. Everything else is implicitly denied without writing a single deny rule. Here's the trap. You allowed inbound HTTPS, and now you want to stop the response from leaving. So you delete the outbound rule. Doesn't work. A security group remembers the allowed inbound connection and lets the response pass anyway, regardless of outbound rules. If you want to kill that flow, remove or edit the inbound allow rule. That's the rule that created the trust in the first place. Quick recall before we move on. You're about to open a remote management port in a security group. What should you do with the source address? The answer: lock it to your current IP or a narrow trusted range, and avoid opening remote management ports to the entire internet. For publicly reachable web traffic, expose only the specific service ports your application actually needs. Pause before the NACL section. You allowed TCP 443 inbound on a security group, and users can load the page. Do you also need an outbound rule for the response? Answer it before the reveal, because this exact stateful behavior shows up on the exam. Here is what quietly catches people. Every VPC comes with a default network ACL. If you do not associate a subnet with a different ACL, that subnet uses the default one, which allows all inbound and outbound traffic. That sounds harmless until you edit it or replace it with a custom NACL. A NACL is stateless. It does not remember that you just allowed one direction of a connection. If you allow an inbound web request, you must separately allow the outbound response. And if an instance starts an HTTPS request to the internet, you must separately allow the inbound response back to the instance's temporary client port. One missing rule on either leg can take down the path for the entire subnet. A network access control list is associated with a subnet, not with an individual EC2 instance. When traffic enters or leaves the subnet, the NACL evaluates that traffic using the rules associated with the subnet. But here is an important detail. If two EC2 instances communicate with each other inside the same subnet, that traffic does not cross the subnet boundary, so the NACL is not used to filter that traffic. Their security groups can still evaluate the connection because security groups are associated with the resources themselves. That gives you an easy mental model. Security groups protect workloads, while network ACLs control traffic crossing subnet boundaries. And because every subnet must be associated with a network ACL, the NACL becomes an additional security layer whenever traffic enters or leaves that subnet. Here is what statelessness costs. A browser opens a connection to your web server. The browser, the client, chooses a temporary high-numbered source port and sends traffic to the server's HTTPS port 443. The server replies from port 443 back to that temporary port on the client. A stateful security group remembers the allowed inbound request and lets that reply leave automatically. A stateless network ACL remembers nothing. Its outbound rules must independently allow the response to the client's temporary port range. If that rule is missing, the response dies at the subnet boundary and the user sees a timeout. The exact ephemeral port range depends on the operating system and service involved. In a public-facing example, teams often allow a broad compatible range such as 1024 through 655.535. Then use more specific deny rules when needed. If you memorize 5 distinctions, make it these. Security groups are stateful and are more closely tied to the resource. Network ACLs are stateless and are associated with the subnet. Security groups only allow, NACLs allow, and deny. Security groups are generally evaluated for a matching allow rule, while NACLs process rules in numbered order. And security groups are usually your primary day-to-day control, while NACLs act as the outer subnet-level gate. This comparison often appears in entry-level cloud certification material, so be able to explain it, not just recite it. A network ACL doesn't weigh all rules. It reads them in order, lowest number first, and the first rule that matches wins. If a Rule 100 allows HTTPS and Rule 200 denies a specific IP range, the packet from that range is still allowed because Rule 100 fired first. So a broad allow with a lower number silently overrides a specific deny with a higher number. Number order is not a tiebreaker, it's the decision. Before we build the security group in the console, quick recall. You have a network ACL with Rule 100 allowing all HTTPS and Rule 200 denying a specific IP address. A packet from that IP arrives. Which rule fires first? Quick retention check before you move on. Which firewall makes you explicitly authorize the return trip? The security group or the network ACL? If you said network ACL, you've got it. It's stateless, so it has no memory of the original connection. The security group remembers and waves the response through. Let's build the security group you would use in a simple web server lab. In the VPC console, click Create Security Group, name it WebSG, and add an inbound rule that allows HTTPS from anywhere IPv4. If the application should support IPv6, add the matching IPv6 rule deliberately rather than assuming the IPv4 rule covers it. Now look at the Outbound Rules panel. A newly created security group commonly starts with an allow all outbound rule. For this lab, that is acceptable. Stateful tracking already permits the HTTPS response, and the outbound rule also permits new outbound connections started by the instance. In production, decide whether the workload actually needs unrestricted egress and narrow the destinations and ports when your security design requires it. Click Create Security Group, then associate it with the intended web server network interface. From a terminal, here is the same SSH rule as one command. Replace the example security group ID and documentation IP address with your own approved values before you run it. Bash AWS EC2, authorize security group ingress hers. Group ID SG0 load 45SAM89 ABCDEF0Rs, protocol TCP heres, port 22Rs, CDR 203.0.1 and 3.10/32. The part that matters most is the CDR. A32 means exactly one IPv4 address. Many teams use the administrator's current public IP or a narrow corporate range instead of opening SSH to the entire internet. A rule for 0.0.0.0/0 is broader than most remote management policies should allow. Confirm your organization's access policy and the SSH port your server actually uses before applying the command. Here's the full path. Inbound traffic hits the subnet-level NACL first, then the instance-level security group, then your app. The response goes back the other way. The security group automatically lets it leave because it's stateful. But that response still has to pass an outbound NACL rule, and the NACL has no memory of the original request. When an EC2 instance cannot communicate, don't start randomly changing firewall rules. Troubleshoot the path in layers. First, check routing. Does the subnet's route table actually provide a path to the destination? For internet traffic, that might mean an Internet Gateway or NAT Gateway depending on the architecture. Second, check the security group. Is the required traffic allowed to reach the resource? Remember, security groups are stateful, so if the original connection is allowed, return traffic for that connection is automatically permitted. Third, check the Network ACL. Does it allow the traffic in both directions? Because NACLs are stateless, you must evaluate the request and response separately, including the ephemeral ports used on the client side of many TCP connections. Think of troubleshooting in this order: root, security group, network ACL, then application. Following the packet path is much faster than adding broad allow rules and hoping the problem disappears. Imagine you're the developer who just blocked a range of inbound ports because they looked suspicious. Your private instance can still send HTTPS requests out to the internet, but the response doesn't automatically come back through the rule you opened. A stateless network ACL has no memory of the connection, so it needs a separate rule for the return direction. If that return rule is missing, the response is dropped, and your page just spins. Quick recall before we move on. Your private instance sends HTTPS requests out, responses never come back. You allowed outbound HTTPS in the network ACL. What did you forget? Here's how I decide which one to use in practice. Security groups are my primary day-to-day access control for EC2 workloads. They answer questions like, which systems can connect to this application? Which ports should be exposed? Should the database accept connections only from the application servers? Because security groups are resource level and stateful, they're usually the better tool for workload-specific access control. Network ACLs serve a different purpose. I use them as coarse subnet-level guardrails. They can allow or deny traffic before it reaches the workload, which makes them useful when you need controls that apply across an entire subnet. For example, you might use a NACL to deny a specific IP range or enforce a broad subnet-level restriction. But don't treat network ACLs as your primary application firewall just because they support deny rules. Their stateless behavior means you must manage both directions of the connection, including return traffic. That can make complex NACL policies harder to troubleshoot and maintain. The simple rule is this: use security groups for workload-level access control and use network ACLs when you specifically need subnet-level filtering or an additional defensive boundary. Defense in depth means two independent filters that don't trust each other. For example, a network ACL can deny IP 198.51.100.7 before it ever reaches an instance. A security group on that same instance still only allows trusted sources on ports 443 or 22. If one layer is wrong, the other can still stop the traffic. Here is one of the most dangerous ways to troubleshoot a network ACL. Your application times out. You suspect the NACL, so you add an allow all inbound rule and an allow all outbound rule. Suddenly, the application works. Problem solved. Not really. You proved that the NACL was probably involved, but you may have also removed the subnet level protection you intended to have. Instead, trace the connection. Identify the source IP, destination IP, protocol, destination port, and return path. Then determine which NACL rule is rejecting the traffic. And don't forget ephemeral ports. If a client connects to your server on HTTPS port 443, the response usually returns to a temporary high-numbered port chosen by the client. Your outbound NACL must permit that return traffic. Troubleshooting should make your rules more precise, not permanently turn your firewall into allow everything. When traffic breaks, VPC flow logs can help you see the flow's source, destination, ports, direction, and whether AWS recorded it as accepted or rejected. That is useful for narrowing down which leg of the connection is broken. But a reject record does not usually name the exact security group rule or NACL rule that caused the rejection. Read the pattern. For example, an accepted inbound request followed by a rejected outbound reply points you toward the NACL return path. A single rejected inbound request can point toward the NACL or the security group on the target resource. Check both layers, along with the route, and use Reachability Analyzer when you need hop-by-hop evidence of the blocking component. Quick recall check. A malicious IP is hammering your web app. Should you block it with a security group or a network ACL? Instead of memorizing every CLI flag, focus on what a NACL deny rule must describe: the direction, the deny action, the protocol, the port or port range, the CID, and the rule number. For an inbound rule, the CID is the source. For an outbound rule, the CIDR is the destination. The rule number controls priority. Lower numbers are evaluated first, and the first matching rule wins. So if you want to deny one malicious IP while allowing a broader range, place the narrow deny rule at a lower number than the broad allow rule. Always verify the exact CLI syntax in the current AWS command reference before running it. Open the VPC dashboard, go to Network ACLs, and select the ACL attached to a dedicated training subnet. Do not begin by editing a shared or production NACL, and record the existing rules before you change anything. On the Inbound Rules tab, click Edit Inbound Rules. For this demonstration, add Rule 100 to deny TCP port 443 from your test IP address. Then add Rule 200 to allow TCP port 443 from the intended sources. The numbers are the lesson. The narrow deny must come first, because a NACL evaluates from the lowest rule number and stops at the first match. Before testing, confirm that the outbound NACL already permits the required return traffic. Save the rules, test from the blocked address, and separately test from an allowed address. When you finish the lab, remove or document the temporary test rule so it does not surprise you later. Here is the full round trip. A browser request crossing into the public subnet is evaluated by that subnet's inbound NACL rule first. Then, the security group on the web server's network interface decides whether the request can reach the application. The server sends a response. Because the security group is stateful, it allows that response to leave even if an outbound security group rule would not otherwise allow a new connection on that path. But the NACL is stateless. The response still has to pass the subnet's outbound NACL rule, which must allow traffic to the browser's ephemeral destination port. If that outbound NACL rule is missing, the browser never receives the response. Here is the trap. Do not treat every default as if it behaves the same way. When AWS creates a VPC, it also creates a default NACL that allows all inbound and outbound traffic. But when you create a custom NACL, it begins with the unmodifiable asterisk rule that denies traffic not matched by one of your numbered rules. Security groups are different again. A newly created non-default security group has no inbound allow rules until you add them. Before exam day, be able to distinguish the default NACL, a custom NACL, and a newly created security group instead of memorizing one default behavior for all three. Let's put everything together with a troubleshooting challenge. You have a public EC2 web server. Its subnet has a route to an internet gateway. The security group allows inbound TCP 443 from the internet. The Network ACL allows inbound TCP 443. And the outbound Network ACL allows TCP 443. Everything looks correct, but users connect to the website and the browser still times out. What's wrong? Think about the return trip. The browser connected to port 443, but the browser did not necessarily send the request from port 443. The client selected a temporary ephemeral source port. When the server responds, it sends traffic from TCP 443 back to that temporary client port. The security group remembers the connection because it's stateful. The Network ACL does not, so allowing TCP 443 outbound in the NACL is not enough for this return path. The outbound NACL must permit the appropriate ephemeral destination ports required by the clients communicating with the server. That's the difference between memorizing NACLs are stateless and actually understanding what stateless means when you're troubleshooting a network. For the exam, make sure you can answer these without hesitation. Security group, stateful, resource level, and allow rules only. If an inbound connection is allowed, return traffic for that connection is automatically allowed. Network ACL, stateless, subnet level, supports both allow and deny rules and evaluates numbered rules starting with the lowest number. The first matching rule wins. Know the defaults too. The default Network ACL created with AVPC allows inbound and outbound traffic. A custom Network ACL starts restrictive until you add the numbered rules you need. And a newly created non-default security group starts with no inbound allow rules. But don't just memorize the table. If AWS gives you a troubleshooting scenario, follow the packet. Ask where the traffic is going, which subnet boundary it crosses, which security group protects the resource, and whether a stateless NACL needs a separate return path rule. If you can reason through the packet, you won't have to guess the answer. When the interviewer asks you to compare the two, don't ramble. 3 crisp sentences. Security groups are stateful firewalls at the instance level with allow rules only, so return traffic is automatic. Network ACLs are stateless firewalls at the subnet level with allow and deny rules evaluated in order. Together, they create layered security, a coarse subnet gate in front, and a fine-grained instance lock behind it. That answer alone moves the conversation forward. If you remember only 3 things from this video, remember these. Number 1. Stateful versus stateless. Security groups remember allowed connections, so return traffic is automatically permitted. Network ACLs remember nothing, so you must evaluate the request and response separately. Number 2. Resource versus subnet. Security groups protect individual workloads and provide allow rules. Network ACLs protect subnet boundaries and can both allow and deny traffic using numbered rules. Number 3. Troubleshoot the packet path. When traffic fails, don't immediately start adding firewall rules. Check the route, check the security group, check the network ACL in both directions, and then check the application. If you can explain those 3 concepts and troubleshoot a simple HTTPS timeout involving ephemeral ports, you understand security groups and network ACLs well enough to move beyond memorizing definitions. Now prove it to yourself. Open your AWS training account and build one. Next in this series, we will unpack the two AWS gateways that get mixed up constantly: the Internet Gateway and the NAT Gateway. More importantly, before you click away, apply today's two layers in a safe training environment. In your AWS training account, create one security group for a web instance. Then, on a dedicated lab subnet, create or edit a NACL that is associated with that subnet and add one documented inbound rule. Before you test it, make sure the outbound NACL permits the matching return path. Do not use a shared or production NACL for your first experiment. That hands-on console work is what makes the difference on exam day and in interviews. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson, build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.